See, so do you know what is the difference between rate and ratio? So ratio
Rate is like
is,
how fast something is.
sorry.
Rate is like how fast something is.
Yes, very good. Ratio is basically, it is defined for, it is defined it is defined for two same quantity, two same nature of quantity. You can say two same nature of quantity. For example, you can take the ratio of $5 is to $100. You can take the ratio of 1 hour is to 24 hours, right? It means both are in the same unit, right?
Yeah.
But rate, what is the rate? Rate is a ratio of, it is ratio of two different quantities, two different quantities. Let me explain with an example. For example, someone is saying $10 per hour. See, this is again a ratio, but it has two different quantities. In the numerator, you have some financial
Oh,
matter, that is the something money, and in denominator you have the time. So rate is a basically ratio. It is also a special kind of ratio of two different quantities. But by default, ratio is, in general we study ratio that is defined for same nature of quantity. Is it okay?
yeah.
Now, what is the meaning of, now we have to explain rate of change of y with respect to change in x. So first of all, please see how we indicate change in y and change in x, right? So change in y is defined as this symbol, that is the change in y, delta y. Change in x is defined as delta x. Now I have to take the ratio of these quantity, so the rate will be delta y upon delta x. Is it okay? Have you understood this? The
Yeah.
meaning of rate of, it means you are going to take the ratio. Which two things? The first thing is change in y, and the second thing is change in x. So rate of
Thanks.
change of y with respect to change in x means delta y upon delta x. Now from here you should know, you, I think you have the idea how we can relate this delta y upon delta x to dy upon dx. See, dy upon dx, what is the meaning of this dy upon dx? Let me explain.
Gradient.
That's another thing, gradient. Okay, see, this rate of, let me explain, rate of change of y with respect to change in x. See, this rate may be of two type. One is average rate. You can think of about your speed, average speed and instantaneous speed, or you can say instantaneous rate. Do you know what is the average speed and instantaneous speed?
Instantaneous. Is it like at that current moment?
Yes, at that current moment, at instant. So how we can define, how you can find instantaneous speed? Do you know how we can find instantaneous speed?
It's speed equal to distance over time.
Okay, then how you will define average speed? There is a
That's the
question.
total distance traveled in the total time.
Okay, it's a total distance, just a minute, it's a total distance, we are talking about average speed. So total distance upon total time. And what was the instantaneous speed? Can you repeat once again?
Or the distance over time. Was it?
How you
Yeah.
can define distance over time? I'm saying about what is the instantaneous at t equals to 2 second. I am talking about at t equals to 2 second. How you can find at t equal to 2 second distance? And what will be your time duration? at t is equals to 2 seconds, what will be your time duration? It will be 0, isn't it?
Yeah.
At t is equals to 0, what will be your time duration? Is it 2 seconds? You will divide it here 2.
No, no.
No, that's, you have to take the time duration. You are interested at t is equals to 2. The instant it becomes second, your clock should be stopped. So I think your time duration will be very near about to 0, isn't it?
Yeah.
So that's the basic understanding of average and instantaneous. So average speed you can find very easily, total distance upon total time. Now the question still exists, now the question is still present, how we can define instantaneous speed, how I can make time 0. Are you getting my point?
Yeah.
So that's the question. You are driving a car and I'm interested in finding your instantaneous speed. So if you divide something by 0 or near to 0, right Rishit, if you divide anything near to 0, your resultant quantity will be infinity.
Yeah. Yeah.
So that's the problem. So what is the solution? Can you tell me?
Mm.
And we have already discussed these things. No? Should I explain again?
Yeah.
See, I want to explain again because I know this is a very fundamental and this is a very basic knowledge which you will need in your higher classes. So I am ready to explain once again. Rishit, if we see a coordinate plane, this is the x-axis, this is the y-axis, and if we are interested, we have a straight line. Let us suppose we have a straight line, and in this straight line, let us suppose we have 2 points x1 comma y1, and another point is x2 comma y2. It means its x coordinate is x1 and its y coordinate is y1, its x coordinate is x2, and its y coordinate is y2. Then I think you have remembered that we are getting here a right angle triangle. As you can see here, let us suppose this is point A, this is point B, and this is point C, and this gap, this length will be x2 minus x1, and this length will be y2 minus y1. Right, Rishit? Are you getting this
Yeah.
point? Have you remembered this? We have discussed. So here we have defined the slope or gradient, right? So what is the gradient or slope? The when you extend this line where it cuts the x-axis and anti-clockwise direction theta, and we have to take the tan of this theta. Are you getting this right, Rishit? Have you remembered this concept? So this theta will be same as this theta. It's a corresponding angle. So we have to take the tan theta here. So when you apply the tan theta in this right angle triangle, you will get perpendicular upon base. That will be the y2 minus y1 upon x2 minus x1. What it is? Y2 minus y1 is change in y upon x2
Yeah.
minus x1 is change in x. Are you
Yeah.
getting? This is something related to change in y upon change in x. Are you getting my point?
Yeah.
Your
Yeah.
gradient gives you change in y upon change in x, but this is your average. This is your average, or you can say instantaneous. Here for a straight line, it's an instantaneous, it's an average. Both are same. Why? Because in straight line, gradient or slope is always fixed, always constant. You can find the gradient by taking any 2 points lying on that straight line. Is it okay?
Yeah.
But now you will remember, now you get remembered that if, let us suppose my graph is like this, something a curve, right Rishi? And now I have 2 points again, that is the point A, x1 comma y1, and this is the point B, that is the x2 comma y2. And I'm doing this, I want the gradient at point A. I want gradient at point A, right? Or you can say I want instantaneous rate of change, instantaneous rate of change of y with respect to x at x is equals to x1. right, Rishit? So this is the point x is
Yeah.
equal to x1. First of all, this is not a straight line, right? So your gradient is going to change at each and every point. Is it okay?
Yeah. Yeah.
Now I am starting my calculation with the same assumption that this is a, this is b. So this will be your x2, this point will be your y1, this point will be your y2,
Why?
right? Now I'm doing the same thing, making a right angle triangle here. This is a right angle ABC, and so if this is the angle theta, can I apply here tan theta is equals to P upon B? Can I apply here this? This will be y2 minus y1. This will be x2 minus x1. So Rishit, can you tell me, can I apply here y2 minus y1 upon x2 minus x1? Can I apply here directly? Is it correct to write
No,
here?
because the line is curved.
Sorry?
The line is curved, so you can't.
Yes. Now I think you have remembered that we have discussed these things.
So you have to draw a tangent.
Yes, because this is not a straight line, this is a curve. This is ABC is not a triangle. Now in present case, ABC is not my triangle, right? So, but we can assume this as a triangle. How? When? When this point B will shift very close to point A. Let us suppose here, right? So now this point, let us suppose B dash. So now AB dash is a very small way. See, I am taking a B very very close to A. See, Rishit, I am taking
Yeah.
B
Yeah.
very very close to A. So in that case, AB dash will be assumed as a straight line with no problem. Do you agree with this conclusion?
Yeah.
Yes. In that case, what will happen? This x2 minus x1 will be near about to 0. Why? When b dash will be near to x, what it will be? It will be x1 plus some new very small quantity h, where you can assume this h tends to 0, right?
Okay. Yeah.
Then when you will take this difference, when you take the difference between x coordinate of a and b dash, sorry, when you will take the difference between a and b dash, x coordinate difference of a and b dash, you will get near to 0 because both points are very very close to each other. Is it okay?
Yeah. Yeah.
So in that case, when x2 minus x1 becomes near about 0, whatever the change in y, then see, here delta x should be 0. In that case, this is called dy upon dx. Are you getting my point? So what we have studied, dy upon dx is nothing but delta y upon delta x, where this delta x should be approximately 0, or you can say like this, limit delta x tends to 0. This is change in y upon change in x. So this is, and this is. Yes, Rishit, any doubt?
No.
Sure, everything should be crystal clear.
Oh yeah, I think it's clear.
Okay, very good. So So now when you come back to our original speed question, see, I was asking from you that how we can find instantaneous speed. Our time duration should be 0. That's the x2 minus x1. See, that's the same condition is required here. So what you will say, sir, give me the function of distance traveling. Give me the distance function, the function of distance traveling with the time. Then I will differentiate it, right, Rishit? And then I put the
Yeah.
value of t equals to 2. That's the meaning of. So now the after a so long discussion, you get the idea what is the meaning of rate of change of y with respect to rate of change in x is nothing but what? Dy upon dx.
DX.
It takes too much time, right, Rishit? But I think you have enjoyed this explanation.
Yeah.
So now come back to our question and let us try to solve. So, yes, this is the function, Rishit. Let me write. See, this was my dy upon dx. Dy upon dx is equals to minus 2x square minus 7. Work out the values of x. We have to find those for what value of x. See, the rate of change of y with respect to x is 1. It means I have given that its dy upon dx is equals to 1. Then what will be the x? Now, this is a very simple question.
Just substitute.
Yeah, no, no, yes, we have to put the value of here. Dy upon dx is equals to 1. So just put
Yeah.
1 is equals to minus 2x square minus 7. Please find. Please tell me the answer quickly.
Plus minus 2.
See, 8 is equals to I think I have written the wrong data. See here, it should be not minus. How I get this idea?
Yeah,
Something
because then you
square
can't.
can
Yeah.
never be negative.
Yeah, no, I can't mute it.
So I think it should be plus. It's a misprinting of this sheet. So this will be plus. So x square is
Yeah.
equals to 4. So x is equals to
Yeah.
plus
Plus
minus
minus
2.
2.
Please take care. If you ignore this, you will lose some marks.